It's July 9th, 2026, and you're listening to Agentic AI in DevOps with me, Andrey, Fernando, and Vladimir. Welcome. Today's episode is a continuation of our foundational series where we closing the understanding gap between us and people who might be listening to the show, so we could refer to those terms more widely without, explaining it each time. So we did first 5-6 episodes explaining what's the tools, context window, the harness, and all of this. But one thing that we have not covered was a concept of loop engineering. I think we kind of missed it, and I want to close that gap. So we have episode, and then we can refer to the episode and talk like if people ask. So loop engineering, who wants to give the definition of it? Or like, what's your definition of it? I guess I pass the microphone to Vladimir.
Yeah, let's do like I say, my own. I believe for the many terms are now appear inside the new AI world, and from like my perspective, and the loop engineering is when you connect multiple things in an agent loop, basically all together, but it requires several components. Like as the agent must basically able to act, change the things, observe what it was, change it basically. It could be anything. When decide what to do next, how to change the approach and so on. And when check is if the condition now match your goal criteria, for example. So it's mean if it's not match your goal yet, we have to loop again. We have to again make changes, verify that they're correct, and so on and so on. It's why in loop called loop engineering. But in the same time, we have to provide to that loop, to the agent in the middle, a way to collect the evidence, because without the maybe logs or errors, or without that, it's have no idea the goal is completed or not. And we also have to add the constraints, like I said, boundaries, how far it's supposed to go. So basically, from my perspective, it's kind of a Jira task. Definition of done. Define that, give it to agent, and agent will make it from that point to that point. So,
yeah, no, I think what I see like that this sometimes tries to help with is, and I have heard this from many engineers. I don't know if you guys experience or feel it as well. Is that people still are like, oh, now this agents can do a lot for me, like the coding agents, but I still need to be in front of the computer and proving or going a little bit of babysitting the thing, right? So when I started looking more into this idea of the loop, and indeed, I think one of the first times I saw this was the idea of the Roth loop, right? That you just put that around it, and then it's just gonna keep going until it reaches that point. And was, I think, back then a very basic setup, like a script that would just kind of keep calling the AI agent again with the same thing, and just trying to collect the evidence, like Vladimir was saying, to decide have I actually finished the big task. I think when we talked about the agentic loop, it's kind of a smaller version of it, right? Like you do the check until you reach a point. This loop is like a much larger one where you can use this idea of I'm going to give you a very large task and you go into this loop to get it done without me having to be there, like pressing enter, like it's okay, right? This was kind of my experience with it. And I think, again, like the impression is like these start to become more of a thing, because also engineers start to get annoyed of having to be there, like babysitting the thing. And I just want you to achieve this goal without me having to be in front of the computer, right?
Right. Yeah. So it's like a nested loops, right? So you have the agentic loop, which is inner loop, and the outer loop is the loop you build yourself around the harness, making sure that it follows what it needs to be done. And there are multiple problems that people are trying to solve with it. With one of them is a context window limitation, right? So if you need to do a big task, it will not fit into your context window. And the Ralph loop implementation is quite simple. You basically tell the model to go and do the next thing out of the document or something you provide to it. And then it either finishes by itself, or you have a hook that is looking for the context window and it will stop it. And then you just repeat. So you're basically restarting the harness all the time, like restarting the session all the time. So you're not hitting the context. So like that's one of the problems that people are solving with it.
Mm-hmm. Yeah, I can add that I'm a fan of Codex, I would like to say. I use Codex more. And I know that Codex and Claude approach that problem in a different ways. Because at least in Codex, what I notice, as soon as context window is about to end, they run a smart way of summarization. It's not like it's just summary and that's it. No, it's a bit more smart. For example, I know that Codex catch the last 20% of context and pass it through because it's assumed that last part is much more important than the whole previous one. Also, it catches the user initial request, like as how it started, the initial prompt. And everything in the middle, they just summarize. So this how I notice that approach is I just observe the agent and I see like everything, whatever we come up in the middle, I just throw it away. So maybe this is a closer also to how humans think. We get the initial goal, we write it down, we come through some try and errors research, and the last part that we kind of work, we save it as a maybe commit or a pull request, and then we start over as the next iteration. But for the Claude, I think it's a bit different. I don't much use Claude, to be honest, but I think they also do context summarization automatically. But I'm not fully aware of how it works under the hood. Maybe Andrey or Fernando can say words how it works. Claude.
I haven't looked into that because I'm trying to avoid context summarization as much as I can, since it's not the lossless process, so you will have losses in there. Plus, that summarization will also take a part of your next context window. So, like if you think of that as summarization as event, and the session after the summarization event as a new session, which is technically a new session, then it will actually could take a considerable amount of your new session, leaving you less room to work. And so that's why I kind of trying to avoid it, like if I can, and there are tools for that. But yeah, so there are different approaches. Let's leave it there. And there are built-in tools now into the harnesses like Codex and Cloud called. I think in the both of them they called /goal, where you set the goal and then the harness will iterate over that. But that is happening within one session. They might change that. They might you also might instruct the agent to use sub-agents to preserve the main context window. So that is helpful. This is what Kira is doing. Like when you're building the spec, so like you create a spec, which is a lot of work. They will slice it in small pieces, and then it will run a sub-agent for every piece. But the main session will be a supervisor and will use very little of its own context. So it will just feed the context to the sub-agents and validate that the work is done.
Yeah, it's multiple approaches how to deal with the context. For example, like as what I did in the past, I offload part of the things to external system. Like I use this linear as a task tracker just to make a note. Like, this we done, this was done, this was done. It could be just a simple MD file as well, like as any kind of database behavior. People also do that. But goal was a bit of a game changer for me because in the past I have some kind of hooks in the end, but in a Codex or Cursor, your hooks, you have a hook in the end of the whole agent sessions when it thinks everything is done and you can run it again. But Cursor limited only to 5 iteration. So I have to write kind of a script, but now not anymore because we have the goal. And if task is big enough, it's kind of working for a while. I myself, I established a metric how long agent can work without a human. So basically, how long it can work without asking me on the things. And last time I reached 2 to 3 hours without asking me anything, just doing its own completely. But after I reach another problem, I have to think in advance and provide big enough task. So I have to act more like a sub-manager.
Yes.
Which is...
No, sorry.
Yeah, which is if you do, I do it on my hobby project, which is a bit hard because my hobby project is kind of small, and I ended with completing the project, and it was kind of, I did it. I have some small tiny app which works locally on my MacBook, and now it's done. And I basically think, okay, but I have all this harness, goals, hooks, and everything. But the project is kind of done, and yeah, so it's interesting world we live in. So
yeah, I was curious. Like, I haven't used these very long running sessions yet. I think I got used to more the idea of similar to what you mentioned to linear, but then I created like this local backlog with the MD file and like the contract, the spec for each thing. So that in the end, I could actually say like, hey, look at the backlog MD and work on everything that is ready for being implemented, right? But then one question that popped in my mind is like, what was the quality of what came out of this long session in your experience? Because this, even with small ones, I still see it sometimes is a bit like, so curious to hear how it was for
again, probably my expectations is a bit lower, so I not give so complex task, but I find that everything greenfield is working quite well for AI. So I use a bit different approach of software developer. It's basically I make the app, and after I ask codecs in a long running session, I want one new feature inside the greenfield, inside empty space. Same framework, same language, same tools, same using the main one. It's built it in 3-4 hours, done. And after I ask it, merge my feature back in the main one. And this, surprisingly, this part is work, it's understand, it's written in whatever bizarre way. And after we kind of port it to the main app. So this is how I ended with my small, tiny app development.
Interesting. So it's a two-stage thing.
An interesting approach. Yeah.
Yeah.
But
I have,
it works surprisingly good when it's have nothing. It's a greenfield. You probably notice if you ask it, create me a web page that look beautiful. The first one, but when you try to tweak it, it is. So this is approach in the end. So.
Yeah, like if you have something to compare with, it also works really well. So
yeah,
I have like the pet project. Will not go into detail, but anyhow, like first version was written in Python, but then I want to move part of the processing to the web server from the local machine and want to do it in Python. Like let's do it in Go, and I'm like, look at this, make it Go.
Exactly.
So this kind of goal, that would work because it actually has something to look at. It can run that code, see the outputs. It can run what it built, see the outputs, compare the outputs. So it has something to measure against. And that's kind of the criteria it needs.
And I think this is a good example for our loop topic because you basically know what need to be in the end and you know the criterias and you know it's this to that. So I supposed to do it.
So you have end criteria, like is hard part. You need to figure it out. Another thing is that you need to figure out what you are looping over. Like in the programming languages, you looping over the array or map or something. Like so you need to have that. And one experiment that I'm running right now is, that is connected to DevOps. Hence, I mean, the name of the podcast, Agentica in DevOps. Let's get back to that. So you have alerts, right? Some people have alerts that are falling in Slack or whatever they use, Telegram, someplace, and that might get noisy. right? Because alerts quality will vary and the rules that is used will be vary. There is an idea with like AI SRE category where we're just gonna run AI agent on every alert. My take on that's going to be expensive very, very quickly and maybe not very productive. So the problem is like here is that the agent is not very well suited to see your Slack or your Telegram. But those alerts arrive there from somewhere. So there is something that generates them, some rule engine that is actually checking conditions against the rules, and then it generates an alert. And then it would use something to deliver it to the channel where you would read it. And then if that something includes something like SNS, for instance, right, or SQS, or even like the Lambda function or whatever.
The place to store it's maybe a Kafka topic. Someone maybe uses Kafka.
something that is being used to propagate those alerts. Because think, I give you an example. The simple example is Amazon Managed Prometheus, where the alert manager is sending alerts via SNS, and then you plug SNS wherever you want. So what you could do is you can create SQS queue that is a subscriber to SNS and accumulate the same alerts in the SNS alongside delivery to the whatever medium you are used to consume the alerts. So that gives you a storage of all alerts you got, which is programmatically readable by the agent. Which means that with little skill, you can basically pull everything that came in for within an hour, 3 hours a day, and ask the agent to categorize that to the actionable noise or whatever, and then act on it. And within few iterations, you will actually get your channel cleaner. So like not clean, but cleaner. So like I did that experiment and I was able to fix a couple noisy things on the spot. And also the argument for batch processing of this kind is that you might have one event going on within your system, but that will manifest itself through different alerts in the different parts of the system. And that would look maybe unconnected, like when you just skim through those alerts by your eyes. But with the agent connected and like looking at the whole thing, it will able to spot the patterns. And if it has something like Boris MCP connected to it, it will also be able to look up the live data and connect the dots and then tell you like, look, there is actually like one event which is just propagating through the system. So you might see a spike on your load balancer or something, and then like there is spike on a database, and then like something there. It's actually all connected and a part of one event, and that's why it doesn't make sense to run agent on every single alert that comes in. Like first thing is like the alert might be just flapping, so it's like resolved in 5 seconds. You're already burning tokens. And like you need to have a way to stop the agent, say like, well, that's apparently not a problem. But also you might be doing, 5, 10 investigations of the same thing, missing the rest of the picture.
You can't find the root cause by that approach because all the alerts are symptoms and only one of them are the real root cause of the whole issue, actually. And this approach with batching is potentially faster because you process them all together. You don't need to wait for each LLM and it's processing and scanning the system and so on. You batch at least 10 or 20 together and process them all together. So it's not only cheaper, it's also faster. Good.
Yeah, no, I think that context makes sense, right? And it's sometimes people feel like I want to react right away. I think what Andrey mentioned is also a very good point. A lot of these alerts are just like a flapping thing, like it just comes and auto fixes. But it's this desperation, I think, right? Like you want to process as soon as it comes. And I mean, not even that. I think maybe sometimes it's like trying to approach it as if it's a human, like that you would maybe look at each alert, right? And hooking back into the idea of the loop. So then the idea is more like a big enough goal, right? Which would be in this case, for example, review all the alerts of today with enough context and enough tooling for it to do what it needs to do, which is what Vladimir was saying before, right? Like to be able to check, I need to be able to connect to maybe a live environment to read the data, to check code, deployments that happen today, right? So that you have a holistic view, and then you have a nice loop that at the end gives you something that's more concrete, right? And that actually maybe the correct thing. So that's
another,
a nice
another thing is that like you're using the agent, so you're using the queue as a source. Your agent pulls stuff, categorize that into items, and then you tell it like, well, now span sub agent for everything. Like start looping over it.
Yeah, it's actually the systems which you mentioned, the alerting. I need only two type of systems in my life. One is when everything is perfect and there's rarely alerts appear, and another one when alerts is just coming all the time. And I think in general, all the projects are go from one to another. It's just how it's grow. And eventually everyone is ended with a full Slack channel of alerts and so on. You need to be someone to take care of. But everyone is busy. It's a job that no one wants to take care of. I think AI should definitely go and do it for us.
Yeah, I see that. Besides the observability, right, when there might be something going wrong, this you just reminded me of security tools. It's a very similar thing, right? So many false positives and all of this stuff, and you're like swamped with 5,000 alerts, and you're like, I don't even know where to start here. They're high, critical, don't make sense, and then you have a low one that's actually important. So this kind of process would help a lot, right? To do the stuff that no one wants to do, indeed, but it's still needed, right?
So yeah, I guess it's more loops to be run.
Some people say that building your own loop, AI loop, is like the engineering challenge of 2026. So that's what you should be doing. Some people say so. Elsa on topic of loops. So what else many people do is that they would use like Bash, and that would pair two harnesses, feeding the inputs and outputs of one harness to another. Totally works fine. And that's, I think, where most of the people will start, because they would use the tools they know. But last episode when we had with Victor Vedmich, he mentioned the podcast that he was like, there is like a very well established, running, I think, for 20 years now in a Russian speaking community, podcast called Radio T, or like Radio T. And I've been listening it like in the very beginning in like 2007, 8, 9. And the people were discussing AWS and like, MapReduce and a lot of cool back in the day stuff. The last episode prompted to me to check like what those people up to, like on the podcast. And I actually found the tool, like I'm bringing it on because I found the tool that I would like to share with you people. It's called Ralph Hex. It's ralphhex.com.
Ralph again.
Yeah, it's basically, you take the Ralph loop idea and you take a next step with it. You build an actual tool around it. And so if you are looking to build a loop, an idea with a Ralph Hex tool is that it would use Cloud Code. So you have a plan, right? So you put a plan in a certain place in your repository. Then it would use Cloud Code and Codex, like two subscriptions you have, to run through it, and using like one as executor, another one as a reviewer, pairing them together. There is like a graph of execution, how it does it. So it's like basically Ralph Loop taken to the next step and productized. And there are a few other projects implementing Ralph Loop, but I found that one being the most complete. And it actually brings us to one more thing when it comes to the building the loop. If you do something in the loop, you're burning tokens continuously, and you got to have some to burn, which means that in order for the loop to work, you either need to have a really beefy subscription or a very thick wallet to pay for the API rates, or you have, the biggest, the baddest server rack under your desk so you can actually run it locally. But basically, there are certain prerequisites for doing that. And the loop, as is, you can build it, but it will get you as far as your wallet/subscription gets you.
You know what? I actually, before, like I say, a couple of weeks ago, I catch myself by running Codex inside Cursor because I have a bit smaller subscription on Cursor. So I let Cursor run a Codex CLI where I have a bit bigger subscription. This is kind of interesting.
And it's turned into a crazy thing with all of this.
Yeah.
Yeah. No, for me, it was just good. I have seen a lot of this thing with the combination, right? Of the one writes, another one reviews. And I personally haven't tried that. I do separate sessions on the same model. And I question, like, out of curiosity, actually, like, how much do you actually gain from doing this thing across models? Because it's like this, we start having like so many subscriptions and things, and we over-engineer this whole thing around it. Like, and a lot of curiosity, right?
Yeah, I would like to say it depends what you do. Like, it's for like a generic programming, maybe I don't know much it more. But if you want to discuss, for example, I don't know, your room layout, and you want different perspective of different models, and you can loop them and tell them, this is my plan for, I don't know, house renovation or build a new house, for example, write it here, and then ask Claude, Grok, Codex, come up with their crazy, because they trained a bit on a different data, so they may come up with different ideas.
So they also trained to behave differently. So like the OpenAI models, they're very, very pedantic, if you like. So if you ever do the grill me session with Codex, it will drive you crazy by like simplicity of the questions it's asking you. Like, I don't care, decide it for me. Like, I don't need to decide if like it's this or that. Like, let's align on the big decision, but it will ask you about every single small thing it can.
That defeats the purpose.
Claude is kind of opposite, so it's kind of, you don't know, I pick the best option for you. So it actually asks less questions, and then it depends what you want. So you like how granular you want to go, and that also, if you think about applications, so Codex would be a better reviewer because it's more pedantic.
Cool. Interesting moment.
No, indeed. Yeah, I think like for these subjective things, definitely, right? Like a design or like the grill meeting. I think for code, and I'm curious, like, because the topic is the kind of the thing that we work with in different ways, right? Terraform or Python or something more.
Yeah.
Like let's say it's becoming less and less important how beautiful your code is, right? Because now a human is not going to look at it anymore. As long as it works properly, and this is always there, a design choice doesn't really like, as long as it doesn't impact performance, right?
I would disagree, because if it starts to infestate the code with a bad pattern, those will spread because it will use that as example. So I'm not saying you should review all the code possible, but like doing grilling sessions, making sure you align, and like providing the coding guidelines, that is important still, because otherwise it will become unmaintainable with surprising things very, very quickly.
Basically, you mean if the code base is already bad and we run loop on it, it's going to make it even more worse.
I seen on the internet there was like someone like sharing the repository an issue with a pull request. Or like the issue saying like, please delete this repository. It's screwing up our training data like 20%. The code is that bad.
I find a bit opposite. I find the guys who can rewrite your code base for some fee. If you're stuck, just in case you're stuck, they can just rewrite it for you.
I remember this role of vibe code cleaner or something. I have seen floating around.
That one. Yeah, vibe code cleaners, guys.
So there is a lot of consulting work coming down the pipe.
Yeah,
just give it a year or two.
Indeed.
Yeah.
All right, here we're at 30 minutes, and that's in our experience. This is how long people last usually, and I do think we exhausted this topic quite well. For the 9th of July of 2026, there probably will be more to talk about in a couple of months or end of the year, but for now, it feels exhausted. If you do not agree, find us on LinkedIn, tell us, and then it's to be continued. But for now, enjoy your day wherever you're listening us. Bye-bye.
Thank you, and see you next time.
Bye.